Imagine you're back with me when I had to shelter in a hospital during Hurricane Katrina. I had lots of patients that still needed critical medications, and we didn't have IV pumps, we didn't have power, our backup generators went out, we had no cell phone services because the satellites were out. All we had were flashlights and our math skills. In moments like that, dimensional analysis is not just homework, it is survival. Dimensional analysis is consistent and logical, and it helps us to be able to calculate correct dosages. If our patients get too much medication, it could be harmful, it could even be deadly. If they don't get enough medication, they're not going to improve, and our patient outcomes are going to be poor. Dimensional analysis is great because it allows you to cross-cancel units. You're able to insert your conversions and you're left with your answer. Think about it as a medication safety net. If your units don't cross-cancel, that's a cue, it's a red flag that you haven't set up your problem correctly. Next, I want to show you why dimensional analysis is the best method out of all the options that you have as a nurse or a healthcare professional.
I wanted to show you what I mean by cross-canceling and how that is the reason that dimensional analysis is set apart from the other formulas. I have some pretty simple basic questions here just to demonstrate this. However, these medication calculations get a lot more complicated, especially when we're trying to really tighten dosaging based on a patient's weight, based on how much medication they need per minute or per hour. But starting from the foundation and establishing good healthy habits now will help you when these get a lot more complicated. So the first question says an MD orders 500 milligrams of Tylenol. The hospital supply is Tylenol 250 milligrams per tablet. How many tablets will you give? Granted, this is always going to be in generic names, and I have it here in trade names. Don't get tripped up by the details here. I just wanted to keep the language super simple in a way that everybody can understand it. But we're given two quantities, our supply and our order. Here I made them match milligrams to milligrams, but that's not always going to be the case. But we're told on hand we have 250 milligrams per tablet, and our order is 500 milligrams. So we have our first given quantity and our second given quantity. The other thing we need to determine is our unit of measure. What do we need to end up with? We need to end up with, the question says, how many tablets will you give? So I'm going to set up my answer with X amount of tablets is what I need to come up with. If you're not sure how to start this fraction, I always like to start with my unit of measure here. So I need to end up with tabs. It's how I'm going to start in setting up my problem. I'm told that per tablet, so one tab is 250 milligrams. So I'm using that here, 250 milligrams. So I'm going to cross that out. And then I need another fraction. Here's why I love dimensional analysis. We want to cross cancel. So this is what I'm going to put here, milligrams. This question is super easy because the units of measure match, but when they get more complicated and you don't have a matching given quantity, this is a clue that you need to put in your conversion. So my other given quantity matches, so I'm going to add it here. Just use that one. I need to keep this a fraction, and I'm not given anything else, so I'm just going to put that over 1. And then I can cancel these out. I'm left with tabs, which is what I need. And then I'm going to calculate. So I'm going to do 1 times 500. All I have is two things here to multiply, so that keeps it pretty simple for me. And then I'm going to multiply 250 times 1, and then 500 divided by 250 equals 2. And then all I have left up here is tabs. So there is my answer. Moving on down, we have an MD orders, so here's one given quantity, 60 milligrams of a drinkable medication. Of course, in your problem or your patient scenario, you're going to have an actual med here, but I didn't want you to be distracted by that. So again, I'm keeping it super simple. My other given quantity is my supply, which is 20 milligrams per 2 mLs. That's what I know I need to add into my formula. And then my unit of measure, it's asking me how many mLs will I give. So that's how I'm going to set up my question. I need X amount of mLs. I'm going to start my numerator with my unit of measure, which is mLs. I'm given that 2 mLs equals 20 milligrams. I can cross that out now. Now I know I want this numerator to match so that I can cross cancel. My order matches. It's the same unit of measure. I do not need a conversion here. So I'm going to plug that in, 60 milligrams. I'm not given anything else, so to keep it a fraction, I'm just going to put it over 1. I'm going to cross cancel these so that I'm left only with mLs. Now, 2 times 60 equals 120. 20 times 1 equals 20. 120 divided by 20 equals 6. I only have mLs here, so there is my answer.